Mission control. All right, good deal. Okay, good afternoon. This is a session on what we call the OpenPower Solution Builder Community that we are forming. And you'll find out that this is not IBM-led. This is for consumers of the technology to form a group. So my name is Linton Ward. We actually have our names listed in reverse order. So we're going in reverse alphabetical order here. So most of you guys know Chris Sullivan from Oregon State. You may or may not know John Pace, Senior Data Scientist at Mark III, one of our partners. And so they're going to do most of the talking today. So we have a problem. In describing this problem, I don't mean to be negative, but I want to set a stage of reality. But first, a disclaimer. The first disclaimer is trying to be cute. This is not IBM-led. This will be a community-led event, and IBM will be a participant, a contributor, supporting, and so that's what we've been doing so far. This is for people who are builders. Now, when I talk to Jeff Scheel, he's thinking build means software build, right? But this includes the hardware stack, the adapters, the firmware, the whole bit, single server through multi-server, hardware, software, and so the guys will get into that more. And so why are we doing this? What we are finding is that there's a lot to know. If you look at all the vendors that come together as a part of a solution, the knowledge bases, if you look at the ability to Google some of the answers simply aren't on the internet, and some are. But there's a lot of information. So this is really about creating the ability to share and collaborate and to innovate. So we'll see a little bit of that here today, but more to come. Initially, this will be just a forum, and we'll talk through the mechanics. So I'm going to give you some of the introduction stuff. Chris is going to talk about some of the reference architecture and the benchmarks, and then John's going to talk about some of his demos around WLMA and Power AI Vision, and then some asks of the community. I got an email today from one of my colleagues, is in a startup, just left NC State this year to form a company. His question was, where do I get, or can I get, a build of Chrome on Power? Linux, of course. And so I go to Garrett's OSPAT tool, and oh my gosh, I actually found one. And so I sent him back an email with the link. And that's an example from just 2 days ago of the kind of thing that we intend to support with this kind of activity. There's hundreds of these questions. The PowerPort Tune reflector within IBM has probably, half dozen a week or so. We also have, everybody's got email threads of questions that come in. So the ability to have a Google searchable means to allow the community to support themselves, we think, is a very critical answer. So we have 3 goals. First goal is just best practices. So Chris will talk to that a little bit. IBM did a reference architecture, including full-blown software stack, clusters. It turns out a lot of the community wants, give me a single server, give me a stack that's optimized, get the right libs and all that stuff. Very simple, right? Ask a question, innovation. So today, as I mentioned, lots of knowledge bases. There's a little bit of a shock moment to try to pull apart the knowledge graph of what we need to know. I do, again, this is a Jeff Scheel question. Wait a minute, we already have a lot of things out there. What is this going to do? So the idea, the concept is a place where we can formulate a small article with a pointer to existing knowledge bases, GitHub, et cetera, not to replace any of those things, but to assist with the information and synthesis of that information. So with that, I'm going to call Chris to come up, and then we'll go immediately after that, John will present.
All right, thank you. For those of you who don't know, I'm Chris Sullivan. I'm from Oregon State University. I'm from the Center for Genome Research and Biocomputing. And we deal a lot with research computing and trying to bring technologies forward into this space. We get a lot of questions, probably both between myself and Lance, about how to bring OpenPower, IBM-based hardware, Power9, Power 8, into existence. So somebody gets a box, somebody gets something, they want to turn it on and make it work, and they have a specific desire to make that work. And so when you initially go out there and you start looking around, there's very little out there for people to pull from. So we enucleated a OpenPower builders group on the OpenPower Foundation, and there's a forum up there, and we're starting to put those links that you saw on that last slide into the different spaces like GitHub and things like this. We also have started a GitHub page where we can start putting all kinds of build scripts and things like that, and we'll look at that here. So the hardware reference architecture, we've recognized that a lot of people have problems at the very beginning with these machines, racking them, realizing their power and cooling constraints and the types of plugs and the things that they're going to need to make these things come online. Network, people have to start thinking about this ahead of time because these machines don't get the performance you want unless you can keep them hopped up. And so people have to think about these things ahead of time, and they don't want to be reactive. We need them to be proactive. And proactive means that we have to have data out there, accessible and in place for people to help them make the decision before they make a purchase, okay? One of the things that we really want to see up there is how to interact with the OpenBMC. That's an M, not an N, whoops. And the IPMI, because that's the basics under which most people with large infrastructures start deploying and start interacting with technology, and they don't want to have a one-off solution. They want to be able to have a solution that works like all the other solutions, so they can kickstart machines and do all that. And we really want to put those pieces into the GitHub, make them accessible, and allow people to reference them in that forum and see that they're accessible. There's a lot of software that has to make the hardware work, and we spend a lot of time talking with people about how to make the operating system do what it needs to do to enable the hardware. So this is the GPU VMs and the Dockers and all the different pieces and how they take advantage of those different aspects while not losing their performance. Okay, and so from the operating system, which kernel you're running, how that kernel's interacting with other various pieces of hardware, external cards that you've put in, all of this comes into play. Even right down to the RAID configurations we put on the box. People have questions about how to get those RAIDs deployed, especially on Ubuntu. I've got people who want to run ZFS on the operating system, and it's hard to get that to go at first. And so what we really want to have is not just build scripts and mechanisms, but we want to have pathways for people to know confidently that they can accomplish this, and it looks similar to what they've done before. There may be some changes, okay? Lots of different things about the file space, because in the end, the file space ultimately is something you have to make decisions on before you start deploying hardware. How is this machine going to interact with the different file spaces? What file spaces are going to be coming in, and what networks do you need? And so as we go up and down the different stacks, we need to have images for people to potentially just grab the image, DD it onto a disk, plug in the hardware as it's been defined, and start it up and watch it go. And that really lowers the activation energy. We need that searchable so people can see that that's accessible. There's a lot of software-related problems and information that's not accessible right now. So solutions out there, and all of us are going right now to an IBMer that we know, and we say, hey, IBMer, I'm having a problem with this, or I need something to do this, and that person then hits the network of IBMers or knows exactly where to go and funnels us into the right spot. And so what you're doing is you have this barrier between you and the information, and you're creating secondary work on IBM to actually get that into position for their users. We need to remove that middle layer. We need the community to become responsible for this, and we need the community to push this forward. So you can see there's a lot of people in this community. Holy mackerel. I mean, we're way up there on the top right. And this community isn't working together in terms of publishing this information, and this community builder group should help us do that. We would like to see a lot of these different groups either putting information up or us linking to information about what they're doing in OpenPower. Okay, there's a lot of different software stacks. The software, I keep telling people, The hardware creates limits to what we can do, and the software sells the hardware. Okay, so in the end, the software, every one of these software stacks you see here is what we live for. Okay, hardware is meaningless without the software stacks, okay? But to make TensorFlow, OpenCV, and these things work on these machines, optimized, which is what John's going to potentially talk to you about, takes time and it takes effort if you can't know your pathway. And what we want to do is lower that barrier to enter in and take advantage of PyTorch, TensorFlow, Keras, all these different things with full bandwidth and full optimization. That means we have to have these things already up, accessible to the community. So, you know, CGRB collaborates with IBM pretty heavily, and we understood that there was a limit to the software. The software became what enabled people to use the technology, and they weren't going to go over there if they didn't see the software was accessible, already compiled, or already worked. And so we had undergraduates spend a lot of time, actually not a lot of time, I paid them $10 an hour. It was one summer. Ported over 2,000 programs. And these were the programs that were most interesting to us at Oregon State University and the ones that we wanted. But at that point, we started having groups come to us saying, hey, we'll port this, we'll port this. And so what we really wanted to see is that there is a pathway for people to find technologies that have already been ported, already been compiled, and put faith in that, or even potentially communicate to a community, a builder community, hey, do we know if this has been ported? Hey, can we get this ported? And let the community come in and say, hey, I can do that. No problem. We don't have to rely on IBM at every single minute, okay? You know, OpenPower, CGRB, we deployed Power 8 thanks to Charlie. Charlie got me back involved. And, you know, we actually run a lot of different software stacks. I want to make people understand that we don't care what somebody wants to run on these boxes. We want people to come in with their own ideas, and we want to enable them. So that means that I have no idea what's going to come at us, and I'm sure that a lot of groups have that as well. Having the builder community means that somebody can take that question or whatever it is, push it out to the community, and they have a resource to help answer that person appropriately and get them through what they want. So Lance helps us provide a continuous development environment for the CGRB. And Lance here, raise your hand, Lance, there we go. He runs the open source lab. And so what I'm showing up here is in part with Lance. We do this together, and I want to make sure that people understand that. So he helps us deploy this continuous development environment. He helps maintain our Jenkins and all the different pieces, and a lot of the builds are coming out of this. We need that to be more visible through the open builder community as well. We need to make sure people are able to see what's going on and even ask to be plugged into that system. Right now, we're asking people, we want to change that modus of operandi there. So, yeah, whoops, that was supposed to be on the GitHub. Here we go. So our collaboration with IBM really is and has been started with OSU OSL. And the OSU OSL helps us maintain that. We started out with pages where people can come in and start finding some of this information. But in the end, I really like the concept that Jeff has put on the last talk, which is creating a hub where the OSL, myself, and everybody involved can actually plug in their piece of this arm or their leg of this system and actually show how we're all working together and how you can leverage this. So let's go here. Here we go. OSU, OSL, and then the GPU request. So we realized that there was a lot of limits associated to people moving onto GPU hardware. And we constantly got this question because we're working in this space. And as I keep getting these emails and these phone calls, what we realized was a lot of people were just intimidated by them and they needed to interact with the hardware. And so they didn't know what to do, they didn't know how to do it, and they were intimidated at the beginning of just even compiling. And so we created this request form so people could get access to GPU hardware on AC922s, and Minskys, all kinds of different things. And we compile the software for them. And we deploy that for them so that way they can initially start to use it. Once they get onto the thing, they're in. They love the performance, and they're willing to start spending more time compiling their own things. This is where we find them pulling down already compiled packages for Power 8 that aren't optimized for Power 9, and they don't know about these things, and that's the problem, is that the builder community will help us communicate to them that they don't want to be installing binaries that were optimized on the Power 8 boxes because you're not getting your throughput on the Power 9. And so we need to show them that these things exist and how to overcome those problems and get back all the value of the hardware they've been purchasing. Okay, now I have some numbers. We love benchmarks, okay? And this is what brings people to the table, is the benchmarks. We actually tested the EPIC 7601 for AMD. We were the group who got those in the front of everybody else. We ran those against a really fast Xeon that we had, a 3400 megahertz Xeon, and we ran that against our Power9. And as you can see, the Power9 wins just with one thread, but as you thread up, oh my goodness, okay? And so what we really want to show is that if people join into this builder community, they're going to be able to see these values, they're going to be able to take advantage of this, and they're going to be able to request these kinds of things to be done so they can see what the impact is on this different hardware. People, when I started showing them this information, immediately started to pay attention to the power boxes, okay? Because when you're going at less than half the time and simulations are going for weeks on end in research world, you just cut the time in half. That's massive, okay? So we also did a lot of benchmarking on the GPUs, and this became alarming to us. And this is what needs to be up in the Open Builder community as well. So if you look over here, this is the total number of events that can be accomplished in the same amount of time. Now I want you guys to appreciate that that DGX2 is a brand new bleeding edge piece of equipment, and it's running at 2.7 gigahertz, okay, compared to our 2.2s on the others. Now, an AC922 just on the CPU will do almost 3 to 4x the number of iterations in the same amount of time. That right there fundamentally causes people to start buying the Power9 box, okay? Just because, I mean, it's just pure numbers. You've got a faster platinum Xeon being beat by the Power9 that's been out for a couple years, okay? So, as you can see as you go down, we continued this process. Yeah, the Intel box kept winning the memory, and that was an important one. It was because the benchmark tool that we were running had SSE, SSE 2, 3, 4 MMX-based libraries in it, and they were taking advantage of that on the Intel side. And so we recognize that people will misunderstand these, and we need to explain these in the Open Builder community. We need to explain why things are certain ways and what benefits you're getting and why they would be looking different with different benchmarks. As we continued down, we broke out SSD versus NVMe. So on some of them, we can run SSDs to show the SSD comparison, and on others we run the NVMe. In all cases, I want you guys to appreciate the AC922 wins on the CPU and the I/O. This is really, really important because this is the world we're moving to. Data, 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 data. It's only about data. And so as you move forward, CPU and I/O became the limiting steps in everything. With that, I am going to hand it off to John.
Wow, that was great.
Thank you, everyone, for coming. Thank you, Linton. Thank you, Chris. I am going to completely switch gears here. Chris has talked about it from the hardware perspective. I'm going to talk about it from the data science perspective. Any data scientists in here? Oh, good, very good. So I'm going to approach it from the part that I use all the time, which is Power AI, or Watson Machine Learning Community Edition. Y'all, I'm just going to say Power AI if that's okay, because it's always going to be Power AI no matter how many times IBM remarkets it. There's Community Edition, that's the one we use, Power AI. We have not had any success in moving to the bigger version. They call it Accelerator now. But if you don't know what Power AI is, it's basically a bunch of frameworks that come pre-installed on the AC922, and they're optimized for the AC922. We've got some of the developers back there who work on making these things run well on Power, on the AC922 in particular, and I'm very grateful for them because they make my life much easier. So you can see the frameworks that are there: TensorFlow, Caffe, TensorBoard, Nvidia Rapids, and I'll talk about those as we go. Okay, so Community Edition, this is also known as Power AI Vision, or I'm sorry, it's Power AI. But then there's another one called Watson Machine Learning Accelerator, which is sort of a bundle of several servers put together that has Spark that's utilized to manage the jobs and all of that other stuff. It's a little bit bigger than what we've dealt with customers. Okay. In Power AI Vision, if you've never seen Power AI Vision, I'm going to show you some demos of what we've done or what I've done with it. Power AI Vision is a pretty cool tool which will allow you to, it's all GUI based, allows you to import images, label them for classification, object detection, segmentation, and now even action detection, which is kind of cool. And then you can label them, then you can create models, and then you can even export those models, which can be used for inferencing on other servers, on Power servers, Intel servers, FPGAs. I think even on your phone, if you are able to get your model down small enough. So this is fantastic. We use Power AI Vision all the time, and I think I can say this out loud. Is this being recorded? Okay. We use this as a tool to be able to sell Power servers, right? Anything you do visually with computer vision, people stand up and they notice it. And with Power AI Vision, it makes it very easy. And so it's a great way to talk to customers and show them, look, this is what the AC922 is capable of. And then we can go into more detail from there. Okay, so with the demos, here's what I'm hoping to accomplish is, from what I can tell, and from all the workshops that have been out with Charlie and others, there are not a lot of people who are doing end-to-end solutions with Power AI or Power AI Vision, and we need that, all right? This stuff is very good. It's running on very good hardware, but we don't have anybody doing end-to-end. Why is that? Well, any answers? I don't know. We're working on it, and we need other people to work on it. Part of the problem is I don't think enough people know about this. And I know that in my daily work of using this, there are some challenges that I hit, especially with the frameworks that are out there and even things like Nvidia's Rapids. All the documentation for TensorFlow is written by Google. They write it for Intel processors, so sometimes it's hard to make it work on Power because you have to change it up a little bit and there's no documentation. Rapids does the same thing. So as a community, rather than me spending 4 hours figuring out an answer, one of you guys may have already done it, okay? And we can share that. If you go to Stack Overflow and you type Power9, TensorFlow, I'm having this error, you're probably not going to get anything. That's what we need, is something like that. We can be so much more productive. We can sell so much more Power hardware if we are communicating with each other. There's no telling what you guys have done that I could really use your information on, and vice versa. We can go a lot further with that. So, what are some of the applications that you guys are creating, or you see people creating that are out there? I've seen people do all kinds of interesting stuff with it, but I'm not sure everybody knows about that. So share our experiences. What are the challenges that we're facing when building our applications? I've gone to Chris with some of these. We had a customer who, I can't say who it is, but they had an Intel server, several Intel servers. They're cancer researchers. They had this nice pipeline that worked fantastic, ran great. We sold them an AC922. They go to run it. It doesn't, OpenCL doesn't work on Power. Their pipeline doesn't work anymore. They're like, oh yeah, send us 4 more AC922s. So I'm being very facetious there, but you get the idea. So we need to work with them to overcome those challenges and those barriers that are there. That's how we do this together. Tips and tricks for improving applications, and then how do our applications perform in comparison to Intel-based solutions? Chris mentioned that a little bit, and I'll show you some more. And then other documentation. So I'm going to show you a 1 minute video of some demos. Before you start that, it's going to be 2 things. One is a demo that I did for City of Tyler in Texas. It was done completely with Power AI Vision. This is object detection. It's done from a dash cam out of a police car, and it detects cars and police officers and some other things. It was literally about a 2-hour project, and you'll see how well it came out quickly. The other one is Tombstone, where I've created a pipeline that will, you can take video of a tombstone and it'll actually transcribe it. And that was done using Power AI, not AI Vision, but Power AI. So you'll see both of them. So, okay, go ahead. And if you've never seen object detection, what you're going to see is video playing, and there's going to be boxes around the various things that it's finding. It's only 1 minute, but I'll kind of explain it as we go. Wrong screen.
Okay. Is that it?
It's not up there. Awesome demo, huh?
Looks a little sandy.
It is a little sandy, yeah. You'll see the cars going by in a second.
Is
There
it
you
coming
go.
over?
Yeah, it's moving. Perfect.
Let's see how agile I am.
Engineers. Okay, yeah, just go ahead and start.
See,
Okay. So this is the dash cam video. Each of the different boxes that you see there, like the pink one is finding a truck, yellow is finding a person. These are cops working an accident that happened. And literally this was done in 2 hours. I took other video from YouTube and some other stuff. We labeled pictures, all done in Power AI Vision. This is a great way for us to talk to the customer about what can be done with computer vision and how quickly it can be done, especially with Power AI Vision. The next one that you're going to turn to is, this is a tombstone, and you'll notice each of the various boxes is for a letter, and it starts to find the letters, and then it actually transcribes it into a text file, which can then be imported into something like Ancestry.com or something. This one was not a 2-hour project. This has been going on for quite a while. This is much more complicated than the cars. So if you want more details on this one, I'll be happy to share because I'm very proud of that one. Okay, so that was done with Power AI. These are just 2 things that I've worked on. Okay, I've got a whole bunch more. What are the things your customers have worked on? I'll be more than happy to share this code. All right, I'll be more than happy to tell how it's been done. If you need the data sets that we used, all the labeled pictures, I have no problem sharing those. For Tombstone, I've got over 51,000 labeled tombstones. All right, I'll share that. Great, let's make it, let's do something good with this. And I'm not a Mac guy. All right, now. There we go. Yay! The Windows guy did it.
You want to hit the, yeah.
There it is.
I think that's also a really important point that John's brought up, is that there can be data sets put into the builder group for training and all kinds of stuff that we've already tagged.
Yep.
When we brought through that you bootstrap off to do your training.
Yeah.
Really lower that time.
Right. And if you've used TensorFlow, you've got all these pre-trained models that are out there that Google's done. We've got those same things too. We did a demo where it counts dominoes. So you put them under the webcam, it'll tell you what your score is. I had 2 of my daughters label those, 15,000 dominoes they labeled. I'm more than happy to share that with you. They needed a job, they were $10 an hour. It worked out pretty well. All right, so some of the benchmarks that we've done. I did some recent benchmarking between DGX1 and our AC922s that were in the lab using time series data. And this was strictly, it wasn't a matter of getting it really good or making super great predictions versus not super great predictions. It was a matter of how does the DGX run against the AC922. And it's not quite apples to apples. The big difference is that the DGX had 32 gig V100s in it, whereas the AC922, we had the 16 gig V100s, but Charlie's hooking us up with some 32 gigs. So we had 4 versus 8, but this was only running on 1. I wasn't doing all 4 and all 8. This is 1-to-1. Yeah, 1-to-1. So I did 2 different kinds of models. I did ARIMA, which is just a standard machine learning algorithm for time series detection. It just runs on the CPU. And then I did something called LSTMs, which is a type of recurrent neural network. The training for it happens on the GPU, and then the inference or predictions happens on the CPU. And it was kind of interesting what I found. I'm going to show you the dirty part, okay? I'm not going to just make everything all peaches and roses. For the ARIMA, the DGX was significantly faster, okay? I don't know why that is. Maybe it's a code thing. Maybe we need guys like you who can optimize the code to make it run faster. Again, this is just running on CPU. For the LSTMs, the training on the DGX was 8% faster than the AC922. Not really a statistically significant difference. That 8% may just be because of the 32 gig version versus the 16 gig version. I don't know for sure. But for one of the important parts was the predictions, the inference. The AC922 actually performed faster than the DGX1. The inference or the predictions for the LSTM run on the CPU. So in one case, the DGX1 using just a CPU, in another case it didn't. So the question becomes, well, which is more important to your customer? Well, do they need it for training or do they need it for inference? So I wrote a blog on this. I can share it with you if you want. This is something you can share with your customers. If they're really looking for prediction speeds quickly, this is better than the DGX, but not in everything. So questions for you guys. Why did the DGX outperform the AC922? I don't know the answer. I can play with it some more and look at it, but if you guys are really good at optimizing code, I'll give you the code. And, Chris has access to all of these servers. We have a DJX if you want to get on and try around with it. You got Nimbix, you got all these other companies. Let's optimize this code. Let's make it faster on everything. And then Nvidia Rapids. If you don't know what Rapids is, when you use Python, there's something called a data frame. It's sort of an in-memory spreadsheet. It's probably the easiest way to think about it. And it runs on the CPU. Rapids allows you to take that data frame and put it on the GPU, and it becomes super fast. Like in some cases, it'll run the same process on the GPU 2,200 times faster than it can on the processor. So it's significantly faster. So I did a bunch of testing here between the standard Pandas data frames that run on the CPU versus the GPU version, or the GDF. And the GDF, in most cases, was between, say, 400 and 2,500 times faster than running on the CPU. There was a couple of tests where it wasn't faster, but I won't go into all of that. But I'll give you an example of why this is important and why this is something we should be talking to people about, and how well it runs on the AC922. Is the same cancer researchers I was telling you about earlier. They're working on it. They have a pipeline of molecular simulation that they do, where they load lots and lots of records up into a data frame, and then that thing gets manipulated for about 10 days. They're just doing data frame manipulations. And I was like, let's put this on Rapids and see how much faster it can go. So we're in the process of doing it. They've been kind of dragging their feet a little bit. But what if we could get that down to 5 days or 3 days? Think of how much more productive they could be. Now, where do you guys come in? The documentation that NVIDIA has for Rapids is all written for Intel, every bit of it. And it doesn't always work on Power. So like even something as simple as reading a CSV file and loading it up into the GPU is different. There's different syntax to it. You have to do a bunch of different stuff, and there's no documentation on it. So you start to do it, and then you start working through the error codes that you get and then trying to figure it out. I've got documentation on it. Maybe you guys have documentation on it, but this is something that's a part of Power AI now, right? And it's still just integrated within it. Let's use it. It's super fast. So I talked about the documentation. NVIDIA's not documenting this. I love NVIDIA, but sometimes you talk to them and they're like, well, go talk to IBM. And then you start Googling IBM stuff, and then you talk to an IBMer, and they start searching through 400,000 people, with an IBM trying to find the answer. And it's tough. It's the same stuff we've all been talking about. So how can the test where the GPU data frames didn't run faster than the CPU data frames, why was that? Can we optimize the code? Rapids is open source pretty much. They'll let you do your own development on it. Why can't we optimize that and make it even faster? And then what are the benchmarks you've performed? Chris showed some of his. Have you done benchmarks with Rapids or with any of these other things? These are things we can take to our customers, whether it's us, we're selling to people, or whether you're Chris and you're selling within your university, or whoever it might be. Let's talk about this stuff. As a hardware person, as a data scientist, as all of these things, that's why we're trying to build this community. So this is just some of the values that we got for loading the data frames. So if you look over there on the far right, loading 40 million records, the load time for loading it onto the GPU, the CUDA data frame, was 1.52 seconds versus loading it, just in the CPU was 76 seconds. 40 million records. Look how much faster that is. It's an enormous speed up. You show that to your customers, it's a piece of cake. Okay, so benchmarks. I've talked about this. Share what you've done, and this is really the asks for the community. Share what you've done with us, whether it's benchmarking, whether it's software, whether it's code, whether it's optimizations, whether it's a new kernel, whether it's a new binary, whether it's a whatever. Chris was talking earlier about out there somewhere about the versions of TensorFlow that you've got. You put on one version, and it's really not optimized for power, so you do some other stuff, and all of a sudden it's a totally different ballgame. It's running much quicker. I didn't know that. I learned that from him today, so could be out there. Give me the image. Let's get that going. Yeah, share your best practices on Power AI, and then how do you make this better? So our big ask is help us out. Let's all work together on this. We've got a great product. It's let's do it. So thank you.
Let's see. We have just a couple of minutes. Are there any questions in terms of engaging these guys? Are we off the deep end? What kinds of things would would benefit. I see Garrett here. I know there's folks who can help answer some of the questions that get asked. You know, can we just take a second and engage in a little bit of dialogue here as we go forward? We're looking for engagement. This is only going to work with engagement.
I think there's some groups out there that are holding a bunch of information that we could leverage in this builder community.
So the community, did you is a proposal or not there live?
No, we're already live. We have the forum established with the OpenPower Foundation. People can join into that forum right now. The links were up there, but we'll make sure that people can get them. We have the GitHub repository already up, and since last week, people have been populating it. Not myself, other people as well. So what we're really looking for is to have established a pathway for people to start putting stuff in and for them to engage with us. And I think that every single time somebody asks a question to an IBMer should send them towards the community, and the question should go to the community and let the people who are already in the community help answer that, even if they have to leverage their IBMer. But start having the conversation from the IBMer be, there is a builder community, let's see if we can leverage that, okay? And then as that goes down that path, we should see more people joining into that community and making it a much more robust situation. Jeff?
Klaus and Garrett and others, I think we need to get Chris and or some members of the community into some of our work groups to explain what's going on here and just do some education and communication. Because I think your biggest challenge, it's great, I like what you're doing, your biggest challenge is going to be getting the message to people to go participate. Because even if we all tell 10 people, that's still not going to be enough. You're going to need to have some path, and you're probably also going to need some regularly gathering time for people that are doing a lot of work to get together. I don't want to call it a meeting because we all need another meeting like we need a hole in our head, but some regular communication path to propagate information and to collect people that are doing work.
I totally agree. I think there's also an aspect where we need people to automatically, who are part of the builder community, put their documentation into that system. I've got a group and this is what I've had, is a person pushing their data from their GitLab repository where they documented everything and just pushing it into GitHub. And so I think that we need to get it out, and we need to get them who are already holding documentation about how they did what they did and push that up. Yeah. Garrett?
I'm going to echo a little bit of what Jeff said there, but amplify. You can't just tell them once to come visit you. You're going to have to tell them repeatedly, and every time you see something that looks cool, say, oh, did you want to put that over here?
Yep.
So we do a Linux board. We cannot get people to put out content even when they've given the answer in some other forum because they don't have time, they forgot, something else came up, and you have to just keep circling back with people. We all want to share, but we don't really want to spend time doing it.
Yeah. And that's why I bring up that concept of documentation. Somebody's going to have documented how they did what they did, so that way if they had to do it again, but getting them to not capture that on their local space, but to capture that into this builder community and get that tone established so that we get more data like Stack Overflow. Stack Overflow's got thousands and thousands of people putting in because the return to them is massive. And so what we have to do is create value so people will come and keep putting more stuff in.
And we need to push them to turn from their notes, which might be scroll, scroll, scribble, scribble, to something that somebody else can read. Help with a fair bit of that.
Yep. I don't know how we're going to deal with that, but
It's mostly asking people, but being repetitive, not being annoying.
yeah. I think there's some curation that's going to have to happen. And we have to realize that if people are putting up junk and starting to search through junk, people are not going to have faith in it and not come back. And so curation is going to have to happen at the beginning. It's going to have to be robust at the beginning, so that way people establish a tone, and that tone is carried through.
Super.
After you get done with the tombstone app, you ought to be able to work on the scroll and scribbling app.
There you go.
Oh, that's a
So Jeff, we're probably out of time, right? Pretty much. Any other questions, comments? These guys will be around for the next day or so. Please, at the happy hour here tonight, have some further conversation.
I think
So,
we as users have been putting the burden upon IBM too much, mainly because we spent money with them and we want them to solve the problem. And that they're trying to struggle because what we're bringing is a unique situation every single time. And they're trying to find a solution to that unique situation. Whereas many of us in the community have already addressed that unique situation and have already solved it. Let's work through that process.
Okay, thank you very much.